Welcome once again to your favorite channel, Israeli Math Concept. In this tutorial, I will profess solution to this given question we have on the board. Let's read out the question first of all. The question says, differentiate y equal to, in brackets, 4x minus 3, all raised to the power of half. First thing first, if we try to open up this bracket, remember the expression contained in the bracket is 4x minus 3. And this expression is raised to the power of half. And to open up this bracket or to expand it is somehow difficult, right? Because the only way you can put this expression, which is raised to the power of half, is by just taking the square root of it. And the square root of it is just square root of 4x minus 3. Using the basic law of indices that states that whenever you have a given base raised to the power of half, that it is the same thing as taking the square root of that given base. This is the exact law of indices I used to put this very given bracket expression in this form. But does this solve the problem of expanding this bracket? It doesn't solve the problem, right? And because of that, we shall use chain rule or function of a function to differentiate this given function. Let's go ahead to do that. Remember that if we want to use the function of a function or chain rule to differentiate this given function, what do? First of all, we shall let a given variable, assuming z, to represent the expression 4x minus 3. 4x minus 3. That is the expression that is contained in the bracket. We use a particular variable, assuming z, to represent this expression 4x minus 3, such that when we differentiate z with respect to x here, we shall have dz dx, and that is equal to differentiating 4x will give us 4, and differentiating 3 will give us 0. So we have 4 minus 0, and that is still 4. Okay? But since we already let z to be 4x minus 3, coming here, we have that our y now will be equal to, wherever we see 4x minus 3, we shall call it z, because that is the variable we use to represent it. Then raised to the power of half. Remember that we are trying to use chain rule to differentiate this given function, such that when we find the derivative of this function here, that is the function y equal to z raised to the power of half, we shall say dy dz, that is differentiating y with respect to z, and that will be equal to, we shall multiply the term z half, z raised to the power of half, we shall multiply it by the power of half, right? Then we subtract 1 from the original power of half. That is the usual method of differentiation, right? And that is equal to, here we have half z raised to the power of half minus 1 will still give us negative half, right? Okay. Then remember that this is the function we are targeting to differentiate, which is y equal to, in bracket, 4x minus 3 raised to the power of half. So to differentiate this function, we say dy dx, that is differentiating y with respect to x, and it is equal to multiplying the derivative of this given function here, which is the y dz, with, that is multiplying it with the derivative of the other function here. And the other function here is dz dx. That is the derivative of it is dz dx. So dz dx. Such that our dy dx is simply equal to, what is our dy dz? Our dy dz, we already solved it to be half z raised to the power of negative half. So here we have half z raised to the power of negative half. Then multiplied by our dz dx, we got it to be 4. So here multiplied by 4. Hence, our dy dx is simply equal to our 2 here, we divide itself to be 1, and 2 divide 4 here will simply be 2. Hence, we have 2 multiplied by 1z raised to the power of half will be 2z raised to the power of negative half, right? But remember that for us to remove this negative half here, this negative sign here, we must take the reciprocal of this given z, okay? So hence we have that this is the sentence as 2 multiplied by taking the reciprocal of this z, we have 1 over z raised to the power of half. So we succeeded in removing the negative value here by taking the reciprocal of this, okay? Such that solving further, we have that 2, remember 2 is the sentence as 2 over 1, such that 2 multiplied by 1 will still give us 2. And that is all over 1 multiplied by z raised to the power of half is still z raised to the power of half. But don't forget, recall that our z originally, we stated z to be 4x minus 3. So recall that our z is equal to 4x minus 3. Okay? Such that here we have that our dy dx, dy dx is equal to 2 all over what is now our z. Our z is 4x minus 3, 4x minus 3. But because we have half here, we can still raise it to the power of half. Such that solving further, we have that our dy dx is equal to 2 all over. The solution to this half here is simply to take the square root of 4x minus 3. Don't forget the basic law of indices I applied here. Wherever you have a given base, taking example x raised to the power of half, it is the same thing as taking the square root of that given base x. Okay, so the same thing is applicable here. We have the expression 4x minus 3 raised to the power of half. So what do? Very simple. We just take the square root of this given expression 4x minus 3. Hence, this is our answer. If you've considered this video useful, remember to reshare this video and as well to subscribe to my YouTube channel, Israeli Maths Concept. You can as well follow me on Facebook to enjoy an exciting maths content of this form. Thank you and see you next time. Remember to reshare this video. Goodbye.